start with the presentation. So, my track is about renewable energy solutions. So, we all know that the energy that's generated to supply to our houses is from fossil fuels. So, fossil fuels are not good for the environment. So, I wanted to find a solution to this by looking at how can you make a sustainable source of energy which is found in everyday life. So there's another source of energy that people use to generate electricity. So it's called nuclear power. So nuclear power, they use the different radioactive elements to generate electricity. So one of the main problems with this type of energy is that radioactive waste produced, okay? So most of the radioactive waste is plutonium-239. So they usually have a half-life of more than 20,000 years, and in that period of time it's very harmful to the environment. So I wanted to, so we know that, so in fossil fuels, carbon dioxide is released, it's the main greenhouse gas released. So carbon dioxide causes the greenhouse effect, which increases the temperature of the earth. So then I looked at air and water. So air and water are the most abundant source of energy. Abundant resources on Earth. Sorry. So I looked at those two and thought, is there a way to generate electricity from them? So water and energy, just a turn away. So the idea is to have micro generators of my own design to be placed in different in water pipes of different diameters. So when water flows through, the discs that are placed inside of the micro turbines start to rotate, causing electricity to be produced. Okay. So you are all familiar with this design. I'm pretty sure you are familiar with this design. So you have a turbine connected to a generator, and when the turbine rotates, electricity is generated. Okay. Now, when I looked at this design, I thought, can something similar to this be put instead of a water pipe? So I made a cardboard model of it to see how it works. So I have a cardboard model to see how it works. How it looks like. So this is the pipe. So in this I have made grooves on the pipe so that the axle can be placed. So there are discs here. So when water flows through here, the discs should rotate. So electricity will be generated because there are two generators on either side. So at this point, I divided my idea into two parts. Okay, a mechanical system and electrical system. In the mechanical system, the main factor that affects the efficiency of my design is the shape of the discs. So I made different shapes of discs using cardboard again. So if you want, you can see them here. So I decided to make a prototype of them. So I have an aluminium discs here, and I made different patterns using M-seal to act as obstructions to the flow of water, and these are pipes here. So what happened was that there were all of these prototypes here suffered from one main problem, okay, and that is water takes the part of least resistance. We all know that. So what happened was that because the discs is not the size of the whole container, it will just flow over it, not causing it to rotate. So nobody wants it to happen to their prototype, right? So I wanted to look at how can I solve it. Then I looked at the T-junction. What I did was that I sealed half of the inlet pipe and made sure that the rotator here is located near the midline of the pipe. So when water passes through here, water is forced to hit the rotator at a tangent, causing it to rotate. And of course I have a ball bearing here to make sure that the rotation is smooth. I took this idea to the next step. I used this design. So there will be a boundary here, so similar to the one here, to make sure that there be something here at the half point. So there's a rotator here. So also when water passes through here, water is forced to hit the rotator at a tangent, which means that the rotator must rotate. So when it rotates, there's a ball bearing on either side. So the shaft generator is connected to the ball bearing, which in turn causes the shaft generator to rotate, which in turn generates electricity. So when I looked at this design, I thought, can I increase its efficiency? Then I came up with this idea. So I decided to use a gear system to try to gain some mechanical advantage. So in this design, I have a rotator here. So when water flows through here, the rotator will start to rotate. It's connected to a gear here. So the gear is very big here, and the gear on the shaft of the generator is quite small comparatively. So when it rotates, I use the principle that one rotation in a large gear causes many rotations in a smaller gear. Hence, I gain some mechanical advantage, which in turn causes the shaft of the generator to start to rotate much more. Then I looked at another design that I could explore, and that was the vortex. Okay, so vortex shape. So I'm assuming we all know Bernoulli's principle, and if you don't know, I'll just tell it. So Bernoulli's principle states that when a fluid's velocity increases, its pressure decreases. So what happens is that when a fluid, or in this case water, passes through a vortex, its speed or velocity reduces. Okay, so that means as a consequence, its pressure must increase. So by integrating this system to that this design, by keeping it at the tangent and increasing, because of the fact that the pressure has increased, the rotator will start to rotate at a much faster pace, causing more rotations on the shaft of the generator, hence causing more electricity to be produced. So yes, and so just like how we have micro generators that generate electricity from wind energy, it's perfectly feasible to have micro generators that generate electricity from flowing water in our water pipes. And remember, this design can be used in any closed system where water flows or any fluid, depending on where water flows through. So it can be of any size, any diameter. Remember, it can be used in the pipes that connect the river to the reservoir, which are usually 5 feet in diameter. It can be used in the pipes that connect the reservoir to our individual house, so 1 feet in diameter. And in the individual houses also, for example, in the independent houses, the pipe diameter are usually 3 by 4 inches. So this prototype can be used in those pipes of that diameter, and it can also be used in pipes 1 inch in diameter, which are used in apartments. So yes, this is a very versatile prototype which can be used anywhere. And I forgot to mention this part, but the cost of actually making this prototype was only 95 rupees. 25 for the T-junction, 20 rupees each for the generators, 20 rupees for the rotator, as I had to cut it from a syringe. Remember, these are all homemade items that I made. So yeah, that comes to an end of my presentation to you all. And I thank you all for giving me an opportunity to present to you all. And I guess, you can ask me any questions if you have any queries. Yeah.
Thank you. That was amazing. I have a quick couple of questions. How long have you been working on this? How long does this take you?
How long does this whole thing take? So I had actually previously had a few other things to add on, but since I didn't make an actual prototype of it, I decided not to talk about it in the main presentation. So that kind of reduced the time span of it. But yeah, this is the main one that I want to talk about.
No. How much time have you spent on it?
The whole project.
The whole project?
Well, it took me around at least a little bit over a week to make all of this.
Okay.
And as for the idea took me a few days to make. So I used this process, okay. So first I looked at what I wanted as a result of my idea. So I used a systematic way of getting to it. First step, I wanted to see how what is the result I want from my idea. In this case, I wanted a kind of prototype that can generate electricity from flowing water. Then look at the principles that are used, okay. the principle in this case is that by changing the shape of the discs, what happens is that the efficiency will increase or decrease. What happens is that when you make more opposition kind of patterns on the disc, automatically more energy will be absorbed by the discs from the flowing water. So it's not rotate depending on how the water is placed. I found out that. So for example, if it's in a tangent, it kind of rotates, it's quite efficient. So then after that, there's also another one, Bernoulli's principle I explained also. So that's another principle that was used and I looked at. Then after that, I looked at what the materials used, okay? So in this case, it was more like aluminium, MCL, steel junction, these generators, this rotator. So that's the main ones that are more important. So then after that, I looked at the, as I told you, I split the idea into two parts, the electrical and mechanical. So I looked at that aspect of it. So yeah, so that's how I arrived at the prototype.
So 2 weeks, give or take. This entire thing you did it in 2 weeks.
Yeah, like that.
More or less. Last one, quick one. So these micro turbines, right? I mean, whether they're micro turbines or big ones, have you thought of how you're going to install them into existing pipes?
Okay. So what happens? I had actually encountered this question before. So I remember someone saying that these pipes in reservoirs, are covered. So how will you cut them? So that's why I came up with T-junction design, because what happens is that there's a hole here for water to come out. So you can just do this. When you cut a pipe, make sure the inlet is around the size of this inlet. Just seal it off in this area, and you can seal it off in this area also. The problem is more or less solved here, and it's just one cut. Okay, so the integrity of the pipe is intact. So there's not much difference in these kinds of in this process. Yeah, I hope that answered your question.
Absolutely.
Have you measured how much energy is generated at each junction?
Yeah, so there's a specific concept you need to understand in this, and that's called the maximum amount of energy generated from a hydroelectric site. So what happens are there are three parameters in this concept. The head, so it's basically, you may have heard of it, so it's nothing but just the height of the water source. Then we have the flow rate, so it's the amount of water that passes through a pipe. And of course you have the acceleration due to gravity. So if you use this formula, which is the potential maximum energy in a hydroelectric site is equal to mgh, m is equal to the flow rate, g is equal to the gravity, so the acceleration due to gravity, and h is equal to
You're aware of the theory.
Yeah.
My question was, have you measured the actual energy that is generated in this?
Okay, so when I'm just gonna give an analogy first, then I'll explain it. So
I think a yes or no would be easier. Have you measured
look,
the energy
so
out of this?
what happens is that if you have, let me see. So when you have an apartment, okay, that's 30. If you say you have a overhead tank that's 30 meters up in the air, and the flow rate is 1 cubic meter, which they measure it. So what happens is that because of the gravitational acceleration being 9.8 meters per second square, what happens is that the available energy in this setup is 29.4 kilowatts. Okay, so what happens is that if you use a micro generator that's just 50% okay efficient, you can generate at least more or less around 15 kilowatts, okay, from this. So what happens?
Still not answering the question. That's fine.
Have you actually done it? Is there a working video of it generating electricity?
Working version of it, well, working video, I haven't done that. No, I haven't.
So, okay, these are still. Okay.
All right, thank you so much.